and today we are going to take a look at the booking.com system design, which is related to the complex problem and involving our knowledge about the strong consistency algorithms and approaches in the enterprise grade systems. In general, we are looking for some functional requirements. Uh, they are about search in for the hotels and rooms, and book the room in particular hotel for one of our users. And in case if we are looking on the non-functional requirements, we will see that we should be able to achieve the strong consistency over the rooms in the particular hotel for our users. That means that two users can't book the same room in the same hotel for the same time. It means that it's not possible to do that through the overlapping period of times. We are looking for the high availability for our search component, and so we should be able to handle 10 million daily active users and 100k bookings per one day, with some possibility to grow. Let's say that after, for example, 3 years, we will have like 100 millions of daily active users, and that would be great. And what is our plan? Our plan to start designing the system, and so during this design we will dive deep through our components design, like we will check the databases and how they will look like, and our APIs. In general, I would like to add that at the end of the system design, we will try to dive deep in the different aspects of the system, and maybe we will be require some backend envelope calculations. But so in general, let's try to move over this plan. First of all, we have our users, and so they will operating with our system through some sort of API gateway. I have this icon which is called load balancer, but let me rename that. So that should be like API gateway. And this component will help us to cover our authorization, authentication, and this will help us with the rate limiting, with different settings for our security. Let's imagine that we will apply OWASP policies over our HTTP requests. So I would like to say that we are operating through the HTTP protocol here, HTTPS. Yeah, so that's our first component, and let's dive deep. Let's say that here we will have some like set of the services which will be auto-scaled. And so first of all, that should be the search service. And this search service will operate with some inverted index storage. What is the inverted index here? So we are speaking about some kind of the system, such as OpenSearch or Elasticsearch, which will help us to do the next. Like we have some like word, let's say some location, yeah, Barcelona, and we will have some amount of the hotels, like the hotels, hotel 1, hotel 2, as a response. In addition, I would say that we should have some ranking over this service, and we should operate through the some user likes, some geospatial indexes for our queries, like the closest place for our user, and some most popular places, the place which liked by our user like years ago, and the sense like that. But in general, so we are stick with this approach, like through the like our uh, our inverted index storage. We may use like OpenSearch or Elasticsearch for our needs, and this case will be covered by this approach. The same we can do, for example, for another city like Lviv. That's the Ukraine, and so we also will have some hotels here, some nice places which we may book, and where our user could live for some period of time. Yeah, so like that. And for making this service highly available, let's try to calculate for now a little bit. So we have like what, like 10 millions, yeah. So we are trying to divide by 24 hours, yeah, and we divide it for, let's say, like 3,600 seconds per 1 hour, and we have the like 120 requests per second. Yeah, so let's say that 10 million divide by 24 hours divide by like this value, and so we will have like this amount of the requests. Let's move it here, and we will say that this is requests per second. Yeah, kind of not so huge, but in general, if we are trying to enable the growth here, then that could be nice to cache some popular locations, and let's add some caching layer here. And so I would say that we will move through the LRU strategy, and so I should say that it could be interesting to like cache most interesting places. Like, let me add the description here. So we store like cache, LRU cache, LRU for by location. Like in case if our user input Barcelona, then we have some cached things in scenario when Barcelona is kind of popular for our for our service. Maybe that's kind of, you know, a little bit over engineering, but in case if we will have like 100 million, then this number will be 1200 requests, and so it could be kind of tricky to handle it, even if we have the autoscaling here. And also, you know, we should move to our inverted index storage, which requires some disk operations. And you know, in general, I guess that it may affect our performance a lot. And because of it, better to think over this caching mechanism here. We will invest more time for this search service maybe later, or in case if you will have some additional questions. But so let's move on and let's try to add another service in our infrastructure. So it will be called like booking room service. And this booking room service will operate with some database. So it's hard for me to think which database we will use for it. But I should say that it will be like some database such as you know, Postgres, because of, you know, in general there are a lot of functionality which is available for this database, and in general I know that we will run all the queries such as create, update, like delete through the master of this database, and like our select queries should be executed through the different replicas. It's possible, and this helps us to to store the information in a strongly consistent way. And I'm pretty sure that we may operate through the Postgres here, and it helps us a lot to achieve these things. So let me try to add more replicas over there. And so that's our storage for bookings. And which information we will have here? So in general, I should say that we should have some hotel, which contains some ID, some description, and some photos, and etc. Like that. Let me move this a little bit here, because we will have another storage over these things. And so that's our like hotel description, and we will have another component here which will be called like let's say room, and the room will also contain the like our ID, description, photos, and etc. And probably we should also have the some hotel to room, like where we will have the ID record, like hotel ID and a room ID. Uh, Here is the trade-off how to store this kind of information. We may store it as some list over our hotel uh, for avoiding the additional join query. But in general, it's possible to optimize kind of this structure, and it's like the normal from the like some normalization form of the database to have the one to many relationship between the hotel and rooms. And so I would like to currently stick with this structure, and maybe we will revisit it later. What do you think, guys? Maybe you may add some comments here, or maybe we should change our database engine to, let's say, some document-oriented database such as MongoDB. But I would like to move through the approach to design the things as simple as possible, and I would like to say that it's better to move currently with the classic relational approach. So we have this service, and here is the trick. Like let's visit our strong consistency over the rooms requirement. And here is the three approaches how we can achieve that. Let's like do the strong consistency. So first of all, let's think about how this should work. Like our user runs some query to our like booking room service, and this service could freeze the room in a hotel for some period of time. And of course, the dates should be involved. So, like, this period of time probably should be like 10 or 15 minutes until we will pay for the our booked room, and after that this like this room should be booked, and all of the operations should be consistent. So in general, I know about three approaches how we could achieve that. So the first one is related to using the pessimistic lock. Pessimistic lock. And so it's about the serializable level of the transaction isolation. So what is the problem of this approach? So like here in our room itself, we will have an additional field which should be like booked. So we will move this field to have the true value in case if someone books the room using the SQL query. And when our user, like some separate user, is trying to get the data about the room for the hotel, we will try to run the select for update query. Like let me print that out, like select for update. Let me try to Google around and show you how it should look like. Select for update. So as you can see, that's kind of mechanism which ensures data consistency in highly concurrent environment. And this approach will show us all the transactions. But the trade-off for that is related to the performance. Performance will be really slow for this situation. And another trick which I would like to highlight, it's about how we will clean our like period of time when user should buy for his booking. That's the question. And one approach, it's just add some bad job here. Let's add it. Yeah, let me try to add this thing. So here is our bad job. Yeah, like bad job for cleaning the TTLs. But here is the trick that first of all, running the bad job in the distributed environment is a really complex stuff. It requires additional observability, additional errors handling, so like additional resources in the cluster itself. And so first of all, it's about some tricky time management. Okay, if that's the case, then let's think about some better approach. Let me remove all of these things here because of they are like not suitable for us. So, and the second approach will be related to using some cache. So let's stick with the technology, the redis. Yeah, redis plus compare and set atomic operations plus the TTL of the record. Let's imagine that here we will add our redis. Let's call it here like redis. And so we will operate with our bookings through the some, let's say, compare and set operation. So how it's possible in Redis? First of all, I hope that it could be great for you to check the Lua scripts for the Redis itself. And so this Lua scripts is executing by Redis engine in a atomic manner. So like in case if you never dive deep in this kind of things and with some log-free concurrency, it's better to take a look on it. Like so what we could Google around like atomic CPU commands. So like there are a lot of different approaches how CPU architectures could use the some commands in the atomic way. For example, in Java programming language, we may take a look on the some atomic data types or concurrent hash map, and they all utilizes the some assembler commands under the hood for achieving the this let's say atomicity for our operation. So, and Redis will guarantee the same for the users. But we should first of all think about the data type. And here is, some bottleneck which we should also have for the Redis, because of, we should run our atomic operation over the dates. So which approach is coming to my mind is about save the room identifier plus some date inside the redis as a key. That's our key. And the value should be like true or false, like booked or not. So, and our Lua script is running across all of the dates, and it will fill the related keys like room plus date to the true state, like all of them are booked. And so here we also add the TTL. Okay, so it's like our approach how we could handle it. And so what is the downsides for this approach? So first downside is fully related to our infrastructure and how we will adopt the redis inside it. Like redis is like in memory storage. It's really high performant event loop, but so the downside here, in case if redis will die for some reason, we will lose the data. What we should do here? So first idea is to just replicate the redis to some database, some another database, or even this one, and do the things like that. But here is the trick. Then in case if we store the data into the redis and one of the instances of our service will die, then this database will not have the record. So if that's the case, if we lost the data here, then it's possible to run some approach how we can synchronize that. Okay, one approach is like to do some two-phase commit protocol, implement it over our booking room service, and stick with that over our operations. But to be honest, I'm not sure if Redis supports two-phase commit protocol. I definitely sure that Postgres should support it, but about Redis, that's the question. Another approach is to orchestrate our so there are some orchestration patterns of the transactions like Saga, and some orchestration approach how to, I don't recall the name, but so we may Google around about it later, how we could escape from this state through the enterprise environment. So it's like, I know that's the outbox pattern, but all of this stuff requires custom coding, requires additional effort to implement it, and I would say that it's kind of complex. So let's take a look at Redis, and there are two approaches on the market for doing the highly available Redis. It's the like Redis Sentinel. It's a highly available Redis cluster. We may do that, but it requires the additional effort again from our team to maintain it. Or we may buy the license. So here is the trick, that we should invest the money here and to do like some third party component in our system itself. That's complex choice, and so you should discuss these things with the interviewer or with your business, how to deal with that. In general, what I should add here, then we also may have another problem. So let's say that we are operating globally. We already discussed this a little bit. And our service is available in all regions. So, and how we support the all queries from our users. And let's imagine that this bookings of the rooms will grow. Okay, so let's assume that we have one Redis, and in case if it will die, then we will have the problem. In general, we may add more Redis instances over our infrastructure, and so some of them will operate in one region. So let's imagine that we have some orchestrator like geo orchestrator. And this geo orchestrator will operate with our booking room service globally. Wow. Yeah, sorry. Booking room service. We operate with it globally, and so in general we are about running some queries over the URAP, and URAP will contain their own Redis, and so the US zone will have their own. So in this scenario, our Redis will be the brilliant solution, and so probably we don't need anything for this kind of things. It's also possible to synchronize the data over the zones. Like, for example, Redis Enterprise will help us to do the replicas and to be completely highly available. Redis Enterprise uses the content replicated data structures for making these things done. Probably that's all which I know about Redis, and let's summarize. So we are going to run the some atomic Lua script for our Redis, and it will book some room ID plus date key, and it will set up some TTL, and so the room will be booked. We mark this as true. The downside here is that we will definitely need to run all of these things atomically, and that could be the issue. Like we should run it for some amount of for some amount of dates for the same room, and that might affect the performance a lot. Here is the trade-off here. So what other systems may give us this opportunity? I mean, the TTL plus atomic things. So potentially we may take a look at the DynamoDB. It definitely supports the TTL, but about the atomic operations over it, I'm not sure. Let's currently take a look at the Redis. But let's imagine that. So what other options could be on our plate? So probably we will also take a look at the most complex option. it's about using some distributed consensus protocols. I would like to highlight the raft here. So let's imagine that we are going to also add the some raft log here. Raft log. And so in addition, we may, escape ourselves from this redis solution. So let me move it to some other part of the screen. Currently we don't need it. Let's move it here. And let's imagine that our service supports the raft log. So what is the approach will be available here. So let's imagine that we have some data format like log ID for our raft, like raft term. That's the special thing which is should be covered by the raft itself. And so in addition, I would say that it will be also the some room ID, start date, end date. So, and how this approach will operate here. So in general, like if we have some consensus, like rough consensus, correct me if I'm wrong, but it's about like n, like count of nodes divide by 2 plus 1. So in case if this amount of nodes are in sync, then the operation will be added to the raft log. And so in case if our user will try to book the room, then we are synchronize the raft log through all of the nodes. Let's imagine that we have just a one cluster without some scaling per zones, and we are synchronized our relational database through this approach. And so in general, all of the parts of our services are exchanging the information here, and we are going to store the data on the raft log. So, and in case if we haven't any conflicts, then we are fine. But if we have, then we should return the values about the conflict, some errors or the things like that to our users. What is the downside of this approach? The main downside is related to the complexity. It's really complex to debug the problems over these raft things, and especially in case if something going wrong or something absent, then we are not about being the lucky guys. So I should say that for some systems such as some clusters like Kubernetes or some databases, Raft is essential solution. But here I would like to escape from it and use our Redis stuff. So let me move the Redis back, and so let's stick with this with the primary solution to do the things. Yeah, so I will move it here, and so here is our arrow. Yeah. So, and the last component which I would like to propose you to do is related to our payment functionality. So let's imagine that we are going to publish our message to some message bus. Let's imagine that it could be the Apache Kafka. Yeah. And here we have some payment gateway service. So, and this payment gateway will operate with the different payment methods. I'm not sure if it's possible to pay crypto in the booking.com, but still, that's the trick. Yeah. Uh, so, like some payment systems such as Stripe, PayPal, bank card payments, and things like that. So, and here your interviewer and maybe your business could ask you about how to synchronize this payment gateway and your booking room service. What I'm talking about, like in case if our booking service sends the request for payment, like, hey, let's initialize the payment procedure for some user. So like we will have the status init payment, like let's mark init payment. So another option to deal with that is totally about, adding another status like in progress. Like what we also may have here, like finish it, and like not finish it. Let's better to have the success and error. So and how to synchronize our payment gateway and booking room service? Probably it could be the good idea to have the statuses over the payment gateway and our booking room service, but it requires some effort from the coding perspective to support these statuses and to apply them through our infrastructure. So that's about the some effort from the development team. And we are looking for some generic system design approach. And I would like to say that it could be interesting to try with something like the. Sorry, let me return back the our statuses. Yeah. So we are looking for something which is called like distributed clock. Yeah. Yeah, I forgot the name here. So, but I would like to say that it's the approach which is highlighted over there some optimistic locking between these two services. So let me try to Google around about it. Distributed clock synchronization. I'm not sure how to give me 1 second. Let me try to find it. Like the sending the requests with the time is not the best idea because of that could be complex to run all of these queries. So let's stick with just the approach, and you will find the related name later. So I would like to say that, for example, this booking room service is sending some payment information like transaction ID, some which obliviously should be empty from the scratch. User ID like book number and things like that to our payment gateway. And we are going to add the like some version to our message. Let's say that we will have the version 0 here. And our payment gateway received this message, and it will assume that we have just a first operation in the sequence here. So it will initialize the payment for our user, and so it will process the operation and increase the version number to 1. So booking room service will receive this operation here, and it will wait for other statuses. So, and this payment gateway, when it proceed with the payment, send back the success message. So we have the 2 version here, and error, for example, will be like also 2. Yeah. So, and if that's the case, for example, if we have some weird consistency over these things, so it's like could be hard to receive some payment information with some different version over the message. I should say that that's about some optimistic locking between the two places, and like some way how we could synchronize the statuses over the system itself. But in general, I would like to say that that's it from our system design perspective. And so what we definitely should add that it's about our API. So here should be some search API, and it should have some parameters like location, like what, like some 2 rooms, like terms, location plus some let's call it options, plus whatever. So we could add some additional stuff over here later. Yeah, like that. And here we should have some book room. Yeah. Book functionality, and so we are going to run it through the some room ID. Yeah, like that. I also so I should remove this, or better to leave it like here, about the strong consistency information, so it definitely will be useful. And let me add the third option here about the rough. Yeah, like that. And so this search service, and the booking room service should operate with some object storage for the working with the images. Yeah, so we should be able to to deal with the images for, I mean, just the search service should operate with the object storage, and here we store the images about our rooms, like that. So in general, that's it from my side, and so guys, what do you think about this system design and the approach which I've used there? I hope that it could be interesting for you. And so I tried to cover a lot of things. Unfortunately, I forgot what is the name of this approach. It's like distributed clock or something like that. I don't recall, to be honest. I should Google around about it. Probably will add some LinkedIn post about the approach itself. And so probably, yeah, so that's all. And send your comments, ask your questions there, and I will wait for your feedback about this system design session. See you later, and bye.